Let's go ahead and try a little bit tougher example, or at least a different example. Okay. So just as a reminder, this is our difference quotient. G of x plus h minus g of x over h. And so this is equal to, and g of x plus h means, again, I'm going to replace the x's with x plus h's. So I have 1 over x plus h, and then plus 1. And minus g, and g is just 1 over x plus 1. And then this is all over h. Okay, and there's a nice little trick you can use to simplify this, right? This doesn't look too pretty right now. We have these two fractions in the numerator, or rational expressions. Okay, so here's the trick. We're going to multiply by x plus 1 and x plus h plus 1 in the numerator and denominator. Okay, so this is actually just the LCD of these two terms that are in the numerator. Okay, and let's see what happens when we multiply by those. I'm going to actually distribute here. I'm going to write a step that you'll probably skip in the future. I have 1 over x plus h plus 1 times x plus 1 times x plus h plus 1. Okay, and then minus 1 over x plus 1, and then this is times x plus 1 times x plus h plus 1. And then let's not forget that this is all over h. And let's also not forget that in addition to this h down here now, we've also multiplied by x plus 1 times x plus h plus 1, right? If I scoot this back up a little bit, okay. Next thing is we want to just see what things are canceling. I can see an x plus h plus 1 and x plus h plus 1, right? If you divide those, they just give you 1. So all we're left with is that x plus 1. Okay. And then if we go look at this second triple here, we can see the x plus 1s are going to cancel. So all we're left with there is x plus h plus 1 all over h times x plus 1 times x plus h plus 1. All right, and we're almost there. So if we were to distribute the negative, we'd see we have, well, x minus x, so the x's are going to go away. And we also have a 1 minus 1, so the 1's will go away, and so all we're left with is a minus h in the numerator. Okay. And minus h divided by h, well, that's just minus 1. All right, and that's it. We're on to our last topic here, piecewise functions. And to get us started here, let's just name this function here h. So we have h of x is equal to, and when we have a piecewise function, we want to write in these curly brackets here. And this is because we're kind of making room so that we can write down multiple different rules here. Okay, and each one of our rules, we're going to need to give its corresponding domain. Okay, so if we were to look at our first one, specifically this line right here, well, it looks like it goes over 1 and it goes up 2. So if we were to do our change in y over change in x, that'd be 2. So that's 2x. It has a y-intercept of -1. Okay, and specifically, this is happening if x is less than 1. Okay. Then on to our next one. Okay, this one's actually just a single point. It's x equals 1, y equals 2. Okay. So it's 2 if x is equal to 1. Okay. And then on to our last rule here. Okay. So this one. Okay. So this one, it looks like it has a slope of -1, so I'm going to have minus x. And if you just actually start here at 1, 3 and you go back 1, up 1, you'll see that the y-intercept must be 4. Okay, and this is if x is greater than 1. Let's go ahead and start example 9. I'm going to scroll down here. Okay. Now, pause the video for a minute and give this one a try. Try and graph this piecewise function. Right, now that you've given it a try, let's start with the first part of this piecewise function, y equals 3 for x less than 1. Okay, so we know that it's just a horizontal line, okay, until we hit x equals 1. Okay, but again, it says x less than 1. No, there's not an equal to there. So this point I'm actually going to plot. I'm going to actually put an open circle here to exclude the point. I want to move that a little bit. There we go. And then to actually get the line portion of this, we have our horizontal line here. There we go. All right. Next step, we're going to start looking at that 9 halves minus 3 halves x. Okay, and I'm actually just going to plug in the endpoints for this. X equals 1, x equals 3. Okay, and then I should just be able to connect those 2 points since it's a line. Okay. So x equals 1, that's going to result in y equals 9 halves minus 3 halves times 1. Okay. And when we do that, we just really have 9 halves minus 3 halves. So we get 6 halves, or how about 3? Right. So that actually means that this point right here, it's going to be included, but not because of the line y equals 3, because the line y equals 9 halves minus 3 halves x. So I'm going to go ahead and actually fill this in. Okay. And then our other endpoint, x equals 3. So we're going to have y equals 9 halves minus, and now not our 3 halves times 3 is actually going to also give us 9 halves. So we're going to get y equals 0 here. Okay. So the endpoint should be 3, 0. So we will have a circle here, but it's going to be filled in because, again, this point's included. X equals 3. And we're going to want to connect both of these points here as well. Okay. And then I'm going to fill it in. There we go. Okay. And then onto the last part, the parabola. Okay. And let's just keep this easy. Let's just plug in some points. How about we start off with x equals 3. Okay. Now do note it's x greater than 3, so we will have an open circle. Okay. So when I do plug in 3, though, this would result in 1. Okay. So if that's the case, here's our open circle. All right, now let's plug in another point. Let's try x equals 4, the next one. Okay. If we were to plug in x equals 4, the y value is going to be 2. And then if we were to plug in x equals 5, the y value is going to be 5. Okay. And now we're going to do our best to connect these points with a parabola. And there it is.